Hello, my name is Trevina. I am a student at UC Berkeley majoring in computer science and minoring in data science. I am graduating in 2022, which means that I am a senior and that I've seen it all. But in high school, I actually was biology and chemistry intended. I spent a lot of time in these two subject areas completing internship opportunities, research opportunities, and even going to the state fair for science. But I got really interested into biotechnology, and that is why I completely switched over to computer science. Although I had no programming experience whatsoever, I didn't take AP Computer Science in high school, I barely took physics, didn't take linear algebra, and basically wasn't really your stereotypical cut out for computer science kind of student. However, I found the transition extremely rewarding and fulfilling, and as of today, I will be an incoming software engineer at Meta. So I would like to think that some of my advice is solid and that the journey has really brought me into great places. So this video will be about why I switched from more sciencey to more computer sciencey, and why I took biology and chemistry and how I shaped those experiences into something strong for computer science. I will also go over the college experience of majoring in computer science, as well as finding work opportunities when you have no programming experience. So, first things first, we start in high school. I decided that I was going to major in biology in college, probably around my freshman or sophomore year of high school. This interest was spurred on by AP Biology, AP Chemistry, doing well on the exam for both, and also landing a research internship at Stanford University where I studied molecular biology and plant immune systems. I spent a lot of time in the lab, and I spent a lot of time doing research, and I even got to present my work at the Alameda County State Fair, and I got selected and qualified to present the same work at the State Science Fair in LA County. These were all super formative experiences, and I could never say that I left biology and chemistry because I lost interest in them. Rather, it was because over the course of my research, I discovered a lot of biotechnology in play, and I was extremely intrigued by it. And so after doing a lot of research and a lot of testing out the waters and seeing how I can maybe merge what I already had with biology and chemistry into computer science, after a lot of that, I decided to just kind of go headfirst and enroll into computer science courses in my first semester at UC Berkeley. So one reason why I decided to consider computer science is because during the course of my research internship, I was exposed to a lot of different technologies, and I found myself wondering more about those technologies than wondering about what I was doing. I also decided that the work environment and work culture for research and academia was very different from what I wanted to do when I was in the workforce. I really love a collaborative office environment. I really love talking with people, conversing with people, collaborating on projects on a day-to-day basis, and really getting that face time with your colleagues and coworkers. And although this is extremely present and can be your case for any person who is majoring in biology and chemistry, the route that I was really interested to go down in that path did not contain a lot of that. In the 2 to 3 years that I worked at Stanford doing my research internship, it was a lot of solo work. And although this is great, and I really grew from it and I really learned a lot, I knew that when I graduated, I really wanted to have an open office culture. I really valued being able to be part of a workforce where people got to intermingle and solve problems together, rather than a culture where every person kind of has their own little piece of the project to solve and can't really collaborate with other people in the lab as much unless you're working on the same kind of paper or publication. In addition, one of the major factors was actually salary and academic requirements. So for me, I knew that I really would like to pursue a career straight out of my bachelor's degree and then come back to school for a master's degree, graduate degree, or maybe even PhD. But that would be a couple more years down the line. I really wanted to start my career as soon as possible, and majoring in computer science gives you the opportunity to do just that, as the majority of computer science graduates at UC Berkeley go on to find their first job within 1 year of graduating. For biology and chemistry, if I were to pursue the same things that I was interested in those fields, it would require a master's degree or even PhD. And although, again, I am super open to graduate degrees, That would kind of delay my start of a career, and I really wanted to start and jump in and start discovering things right away. In addition, there is a pretty significant salary difference depending on where you go and what level of education you hold. For example, at UC Berkeley, the average salary for a computer science graduate with a bachelor's degree is around $119,000 per year. For biology, it is a little bit lower because many people go on to achieve master's degrees and PhDs, and so it is around $86,000 per year. These are very generic estimates, and these are not to be taken as deciding factors of your career, but it kind of is just a little tidbit to put things into perspective. That is one of the things that I personally considered to be very important when choosing my career path. Naturally, when you first start considering computer science, there are a couple basic first steps. You should not join computer science just on the basis of working straight out of college or on the basis of a higher salary or on the basis of all your friends are doing it. And although I did mention those factors earlier, one very important thing is to make sure that you get to test out the waters before you really consider this decision. For example, when I decided to try out biotechnology and learn the computer science side of biotechnology, I took a community college course on Java. I had never worked with Java or any coding language prior to that, and that really opened my eyes to kind of how your brain needs to work and how the logic flows in computer science as opposed to other traditional STEM subjects. Now, it's a lot more problem solving, and it's a lot more applying new methods and critical thinking as opposed to kind of finding out pathways or memorizing vocabulary or plugging things into equations. That was the first difference that I noticed straight away. If you are not at a good time to take a community college course in programming, then I would highly recommend taking online courses. There are a ton of free online guides to computer science and programming on the internet, and you can find a lot of those all over the place. Just make sure that you start with the beginner-friendly language. I highly recommend Python as your first coding language if you've never really touched programming before. If you don't really vibe with Python, I recommend Java. Those two are some of the most important core programming languages that you should know or at least have a taste of before you jump straight into computer science, because your work is going to involve a lot of that. Now, Python and Java comprise a lot of what we call back-end programming. So back-end means that you're going to be working on maybe algorithms or like coding. This is kind of the concept of computer science that many people have in their head when they think of the major. You're writing algorithms, you're developing applications, but it's stuff that you can't see. For example, you are not developing buttons on a website or like a cursor or pictures in a website with Python and Java. Rather, that would be something like HTML and JavaScript. These two languages I would also recommend taking an online course from just so you can understand what kind of programming you would like to do. The logic flow for these programming languages are pretty different from each other, and so I would highly recommend that you try at least one of Python and Java, and also at least one of HTML and JavaScript. Now, there's a lot out there, so you shouldn't be too intimidated, and I know it's super easy to get imposter syndrome and just kind of put everything down and decide that you can't do it. Really take things slow, give yourself the time to process it. It's okay if something asks you a Python or Java question and you have no idea where to start. That's all part of the learning journey, and that's something that I learned to get over, although it was really difficult to get over because I had this career set in biology and I was like doing super basic things that I didn't even understand. But with time, it will come to you. So just keep on trucking until you're comfortable with it. If you are comfortable with it, then I would highly recommend looking into more courses, looking into some courses from colleges or other programming languages. If you are not comfortable with it, then I would maybe reconsider or maybe try a different language, or look up all the different things that computer science majors can do, and maybe start from there. One programming course that I would recommend that is from an actual college is Harvard's CS50. So this is their beginner-friendly introductory programming course. It is taught completely in Python. It assumes no prior programming experience, and it is an 11-week course that can be taken all online. This means that you can do it from wherever. You don't need admission into Harvard to take this. It's open to the public and basically anyone can access it. I would highly recommend this. Also, a quick plug is that UC Berkeley's websites for our introductory computer science courses are also online. So if you would like to search them up, the two names are CS61A and CS61B. I can go over this in more detail later, but CS61A is the very beginner course. It is taught in Python. It basically deals with how to write code and the different types of functions and statements that you would need. And CS61B is planted in Java. It deals with algorithms, it deals with data structures, and basically some of the more complex ways to store data, as opposed to just learning what an if statement is. I would recommend these two if you have the time. As always, online courses always help as well. There is no really right or wrong way to learn computer science as long as you're getting the content and getting your hands on experience with writing code.